Good morning. I'm hoping that this lesson is a little bit shorter. This is simplifying nth roots with a few details. So there just a few little catches and glitches that can happen when we're trying to simplify higher order roots that we just want to be aware of. The first one has to do with negative numbers. Now we know from our previous study of square roots, that is an S, okay, sorry about that. Square roots. Don't you like how that magically changed there? Square roots, that if you try to take the square root of, like we'll say the square root of 4, it's 2. But if you try to take the square root of negative 4, okay, before you blurt out negative 2, make sure that you think about this because we have covered this. This is the square root of 4 times negative 1, which is the square root of 4 times the square root of negative 1. And the square root of negative 1 is I. And so when you take the square root of a negative, you have this, what's called an imaginary number that comes out. And it also can cause like your calculator to error. Okay. Now, but the question I guess that we want to consider right now is, does this apply to other kinds of roots? So we're just going to look at the cube root. Okay. We're not going to try to generalize this to all roots, but we do want to take a look at our cube roots and just see what the case might be. So if we had, say, the cube root of negative 8, okay, we could actually factor that a couple of different ways, but I want you to follow this. I could factor that into, okay, so you could do something, there's actually a bunch of different things that we could do, but this is the one we want to do. Negative 2 times negative 2 times negative 2. Now, over here on the right-hand side, I've got like some other stuff going on. Like you could factor that into negative 4 times 2 and negative 2. Okay. And if you did that, technically this is a correct factorization, but it doesn't factor it into that group of 3 that we're looking for. We are looking for a group of 3, but you could also do it this way, where you factored, well, you could factor it this way into like, say, 4 times negative 2. And then when you factor the 4, instead of factoring it into 2 times 2, which is what you would normally do, you could factor it into negative 2 times negative 2. Now, the point of that is that what we're trying to get when we're factoring it is we're trying to get that group of 3. And so the cube root of negative 8 is actually negative 2, not 2i or negative 2i or anything like that. Now, it does mean that you have to be aware when you're factoring with the negative that instead of factoring out like one negative and getting like negative 2 times 2 times 2, that you actually do need to make sure that you replicate that 3 times in order to get the group of 3. But it works because negative 2 times negative 2 is positive 4, and then positive 4 times negative 2 is negative 8. So it's just one of those little catches. Okay, that's why it gets its own billing in this lesson, because if you just kind of see that on your own, you'll probably stare at it and not know what's going on. So that's how you handle it when you do get those negatives. Here's the conclusion that we draw from that. Okay, the conclusion is that we can take cube roots of negatives where you can't take them, you can't take square roots of negatives. So the square root of negative 4 gives you that imaginary number, but the cube root of negative 8 does give you the negative 2. So it is a little different, and it does actually work for any odd root, okay? But usually if you're looking at odd roots, it's going to be a cube root. It's not going to be a 5th root or a 7th root. In fact, usually the only time that you will see 5th roots and 7th roots is in a lesson like this where you are specifically studying the higher order roots. Most of the time you're going to see square roots and cube roots. That's going to dominate pretty much everything that you ever see. So that was like the special case number 1, just a little special catches. It was, what do you do with the cube root of a negative? And the answer is you factor it so that you have that cube, that negative 3 times, and then you can get it out. Now, the second one, this is actually pretty subtle, and it's one of those things that I do want you to see, but I don't necessarily want you to stress over. So if x squared is equal to 25. The question is, what does x equal? I'll give you a moment to think about that. And hopefully you thought of two things, okay? So hopefully you thought of 5. But if I prompt you and I say, okay, look a little bit harder, I think a lot of you would also come up with -5. And the reason for that is because 5 squared is 25, 5 times 5, and -5 squared is 25. And this bothered me so bad when I was in pre-calculus, when I was a student. It bothered me really, really bad. And I guess I'll show you like what I mean by that, what bothered me. So in math, if you see something like this, the answer to the problem is plus or minus 5. But if it's this, x is equal to the square root of 25. Well, the square root of 25 is just the positive 5, okay? So just bear with me here. And it bothered me because in order to solve this, you would take the square root. And so it just bugged me that, like, why did sometimes you have the plus and minus and sometimes you only have the plus? I don't even know when it stopped bothering me because it just never sat real well with me. And it just has to do with an assumption that we make in math. When we're taking a square root, we assume just the positive. Now you can argue about it, but you'll be on the losing side of that argument. So if the question is given to you with the square root, you only assume the positive. If the problem is given to you as something squared and you would do the square root as a step in solving it, then you need the plus or minus. And it's just one of those things. You don't have to like it. It is what it is. So here's the problem that this poses for our square roots. If you are taking the square root of x squared, we would say that a square root undoes squaring, and so you are left with just the x. But what if x is negative? Okay, we end up with this weird little conundrum. That's a great vocab word for you, conundrum. A weird conundrum. So what if we saw this? The square root of -5 squared, where that would be underneath the square root. Well, -5 squared using order of operations, -5 squared is 25. We established that over here, that -5 squared was equal to 25. And the square root of 25 is 5, which is not equal to x, okay? So if x is the -5, then this is actually the opposite of x. It's like what we call the negative of x, or the opposite. This, you know how I use the word opposite instead of negative all the time. So here's the problem that we have. If we have a variable, okay, and we don't know if the variable is positive or negative, it could be positive or negative. When we take the square root, we have to have the positive. Okay, so here's the conundrum. If we have a variable, we don't know if that variable is positive or negative. We don't know because it's a variable. So we don't actually know what kind of number was plugged in. But when we take the square root, we have to get the positive. So we can't be totally sure that the square root of x squared is x, because it might be the negative of x, like the opposite. And so we have to ensure we get the positive. Now, it just so happens that we know of something that will take something and negative and make it positive, and that is the absolute value. So we actually need to put in absolute values. So the solution is to put absolute value around the variable, and that will ensure that it is not negative. It doesn't, I guess, ensure that it's positive. I should go back and fix this. We have to have, I'll make an amend here. Not negative. Okay, it just can't be negative. It could be 0. I'm getting picky there. Okay. So we put the absolute values around the variable. So here's what it would look like. If you have the square root of x squared, instead of saying just x, you would say the absolute value of x. And that will ensure that it is the positive number no matter what. So if x was positive and you take the absolute value of a positive, then yeah, that's fine. You still get the number back. If x happened to be negative though, then you would be taking the absolute value, and that will ensure that you're getting that positive out. So this is only true for even ordered roots. Okay, so this is, I don't know why I did that. Sorry. I just went to change the color. True for even roots. So that would be square roots, fourth roots, okay, sixth roots, not that you'll ever see those, but anything that's even. You have to put an absolute value around anything that might potentially be negative. So I'm going to do these two examples. These are actually from the last lesson. And if you remember from the last lesson, I said something along the lines of, we're going to come back to this problem because we actually need to tweak the answer to it. So because we're not doing this in one class period, which the original version of this lesson was done in one class period, I actually am going to rework the problems, but I'm going to rework them fairly quickly. So we did this problem last class. You don't need to write it down again if you already have it in your notebook. Just kind of flip back to it, or feel free to write down some of this. So we do that prime factorization, and I worked this out last class with a prime factorization of 81 was 3 to the 4th power. And then we have 4 x's, and then we have 8 y's, and your teacher does not space things well and runs out of space. Your teacher also pays for an app that gives her a pause button, and she can go back and magically respace stuff without taking time in the lesson. It's wonderful. I am going to do a quick count on these y's to make sure I have 8 of them. So 1, 2, 3, 4, 5, 6, 7, 8. So remember, because we have a 4th root, we're going to be looking for groups of 4. So I have a group of 4 3s. I have a group of 4 x's. And then we have, good grief, we have a group of 4 y's. And then we have this other group of 4 y's. And that gave us the y squared. In last class, we actually left the problem here. Now we need to consider this, like, is anything here potentially negative? So here's our reasoning, because we always want to reason stuff out. The 3 is positive. I can tell because it's there and it's clearly positive. It's a 3. Y squared is positive. Or at least not negative, okay? I guess we don't know for sure it's positive, but it's definitely not negative. And the reason I know that is because it is being squared. So if y is a positive number and you square it, you're going to get a positive number out. If y happens to be negative, it actually doesn't matter because you're going to square it, which is going to go make it positive. The one part that we're not sure about is the x. That we are not sure whether or not it is positive or negative. And Miss McDonald is calling me. Okay, now I need to figure out where I was on this. Okay, so like what we don't know about is the x in the middle. We don't know if the x is positive or negative. So we're sure about the 3, we're sure about the y squared. So what we do notationally to take care of that is we're going to put absolute values just around the x. And so really your answer should be 3 absolute value x y squared, or some how you want to say it out loud. And that accounts for the possibility that x might be a negative number. The other example that we did, that I said hang on to this example, was this one. It was the square root of 8x to the 3rd y to the 6th. And again, because it was actually in a previous lesson, I'll just go through the simplification process. So 8 factors into 2 times 2 times 2, and then we have x times x times x, and then we're going to have 6 y's, 4, 5, 6. And remember, if you don't see that index, it's a square root, and because it's a square root, we're looking for groups of 2. So here's a group of 2. Here's a group of 2. And then we have 1, 2, 3 groups of 2. And then we have the square root of 2x. And again, you should have that problem in your notes from yesterday. So how to go through that for simplifying it. Now, because this is a square root, it's an even ordered root, and so we need to watch out for the negatives. If it's odd, and that goes back to that other issue. I'm going way back here. Right here is that if it's an odd root, then it's okay to have the negative. You don't have to worry about whether the answer is negative. So this is something that's only in effect for like 4th roots or square roots and whatnot. I just went too many slides. There we go. So we have to look at these items over here and just decide whether or not they're positive or negative, or if we know. So with the 2, I am confident that the 2 is positive, because I can see that it's positive. I don't know about the x, and I don't know about y cubed. When you cube something, you could get a negative. So x could be negative, but if you have a negative times a negative times a negative, that actually would give you a negative. Unlike with the squaring, where you'd be guaranteed to get the positive. And so we're actually not sure about either the x or the y cubed. And I'm just going to rewrite that because I made it messy. So we would put absolute values around the x and the y cubed to make sure that it was positive. Now, I did want to mention, just with this absolute value thing, this is the kind of thing, it's important to note, it's important to be aware. There's a decent chance that you are going to encounter the absolute values in the simplification of the radicals. It's not a make or break kind of fact. So if you go through the rest of your math career and you forget about the absolute value, it's not going to cause you to fail any math classes or anything like that. It might dock you a couple of points here or there on something. And if you're working with a program like Math Excel, or my dual enrollment class uses a program like that called Lumen, then you might need to put the absolute values in, or the computer won't recognize it. So it's something that I wanted to address. 2 little catches, and now that we've done that, you should be good to go with simplifying radicals.